Okay.
by Anna and me. And this code is used to convert the dependency matrix to MDG file. The logic here is to identify each single non-zero values in the matrix and made a to to output a format, the MDG format in the MDG file. So we use this script.
Can you show us the sample input, sample output, and then you describe us the logic?
Because now we only have the sample input, so I will run it
You run
in
it
the.
once.
Oh, here it download already.
Okay.
100 beacons. Okay. Okay. We use this Python. This is a Python code, MDG generator. It has a few inputs, a few arguments. First one is a dependency matrix. Okay, let me look at this one. Tell you. The first argument is a dependency matrix file. Second argument is the label file, and the third argument is the output file you want.
Okay.
And the fourth one is this one is okay. It's called the orphan module file. I will.
For example, the level, right?
Yes.
Okay.
I will explain you why we need this. And the final is argument is optional, that whether you want the MDG file to be with weight format or without weight format. With weight format means all the dependencies are weighted, like the 1096 just now we showed. And the without weight is just draw the dependency between the packages, but have no values. The dependency have no values. As long as they have the dependency, they will have the connection there. Okay, so according to this, we can run the code. Fruits, cluster detail. No. Dependency matrix. This is the first argument. Labels. This is the second. And outputs. And we call it MDG, like MDG.MDG. Here. Okay. MDG with weight. Maybe.
Okay.
And also outputs orphans. Dot
TXT or CT?
Yeah, it should be TXT. Okay. And then we have dash W. Yeah, dash W.
Dash W denotes with weight, is it?
Yeah, here you can see it's
Okay.
with weight. Without is WO.
W. Okay.
Okay. So we run the code. Yeah, it's finished.
Okay.
Okay, so we come to the output. We can see this MDG file. This is the MDG file. So MDG file the format is like this. First package. That means the one requires the dependency. And the second package means the package it depends on.
The row and column.
Yeah, the second one
Yeah.
called the second one.
The first one
First
calls
one,
the
sorry.
second one for 1096 times. The first one calls the second one for 20
Okay.
times. The first one calls the third one for
Okay.
10 times, something like that.
Okay. Yeah. This is the weighted MDG. If you use the without weight, the number will simply not there.
Yeah. If there is a connection or not, that information only will be there. So it's like you can imagine this as a weighted graph, and when you just go for binary connections, it will be an unweighted graph. There will be no edge weights.
Yeah, like we can also
So
do this.
why do we do this? Is like Bunch can work with both formats. Like it can work with weighted graphs and also it can work with non-weighted graphs.
Okay, with this way you can also try the without weight. That's very fast. Here we have it. You can see they are identical except for the numbers. Right. Okay. So this is the MDG file we need.
Okay, so now we have come to a point where we took the application and came up with the MDG.
Yes.
By analyzing the dependencies, we have come up with the module dependency graph.
Yes.
Okay, now our next step is to fetch this to bunch.
Yeah.
You're going to show us the bunch demo, right?
Yes. And before that, just one thing
Yeah,
is
orphan.
this orphan. You can see there is one package, which is orphan package, which is the 11th one. Just now we showed. Why is this important here? Because the MDG file count only the dependencies. If one package has no incoming and outgoing dependencies, even on itself, it will not be included in the MDG file. So in the later process, this package will be left out. At the end, this package will not be present in the
output of bunch also.
yes. So it's
So
totally
You
missing.
understand what's going on?
Yeah, yeah.
Okay.
So that's why we need to add this into.
But can you put it like util space 0 as the last line in your MDG? Did you try it? Instead of putting it in a separate file, you can put it in the same MDG and then fetch it into bunch.
I think
Currently, how do you do?
Huh?
Currently, how do you do?
currently I add them back after the
Bunch gives the output before Mojo.
Yeah, because
You are proxying for bunch.
yes, because I realized it when I do the extended part. So it's a little bit complicated. I can convert the dot back to CSV
Mm-hmm.
and add this orphan module, and then I convert the CSV to RSF.
So
directly.
the current code is the bunch portion is completely ignorant of this orphans, and you proxy for bunch after bunch outputs the
Yes.
.e file.
Yes, I just put it in
In
the
the-
individual cluster.
Okay.
Okay.
Yeah.
That, that's about the orphan. Now we can move on and we talk about the bunch.
Yes.
I think I better show you what bunch is like.
Yeah.
Okay, this is a bunch tool. It's used to cluster the architecture, recover the architecture of the application. Here we can try to use the GUI, and I can show you. We use our example MDG file like with weight.
Bunches determine your input. MDG contains 11 reflects your adjust bunch, assumes cohesiveness in modules, thus these edges will be removed from the clustering process.
Yeah, that's a problem with bunch because
So
bunch is used for Java program.
Okay, so it naturally assumes there is cohesion
Yeah,
and deletes all the self loops.
yeah.
Okay.
Okay, we try and we use a hill climbing.
So this is the clustering technique. So what options do we have? Hill climbing GA then?
Okay, the clustering method, this one we can also use the agglomerative
Device.
clustering, or we use a user-driven.
Have you ever tried user driven?
No,
Agglomerative only.
because it's actually the same, just you do it manually step by step.
Okay.
And we also have the option here. We can have the population size because hill climbing pick a random point to start with. If we have only a population size of 1, that means we start from only 1 point, and we might end up with a wrong result.
You guys are aware of, probably you might have read about the search algorithms, right? Any optimization that you already tried, like genetic algorithm, hill climbing, gradient descent?
Yeah.
You took any courses on this? I mean, are you aware of hill climbing algorithm? How does it work, or something like that?
No.
Genetic algorithms.
What
Genetic algorithm, GA. No.
No.
Okay, no problem. I was just assuming there is a course in data mining in computer science, right? I see.
Yeah, I haven't taken this
Oh, okay.
course.
Okay. So you were aware of.
No.
Okay. But then again, think of it as a black box, so you need not elaborate much. You can directly go.
Okay. The thing is,
This parameter we can set to any numbers. right?
yeah,
Yeah.
the larger the better, but the larger will take much more time. So
Okay,
in
much
our
less.
experiment, we put 10,000. I remember.
You usually use 10,000.
Yeah.
Okay, so you actually have to educate me also here because I never use the GUI, and you have to give me the right numbers and then you have to say the ranges. Like 10,000 is fine. How about randomize?
Randomized we use 65.
What's the
No,
purpose?
the randomized 25%, and
What's the purpose?
the
What
purpose
does
is
randomize do?
I explain according to my understanding.
Mhm.
That means when the clustering method, the algorithm,
Mhm.
when it goes into a dead end,
Mhm.
will it come back and search for another route, for another result?
I'm not able to understand.
Okay.
We go to that end, meaning what? That particular
Because
place.
that I will need to explain the hill climbing algorithm.
Okay, you have a lot of hills. There's a lot of local maxima, and you will have one global maxima.
Yes.
So you are saying when you are locked in a local maxima,
Yeah.
you need to jump out of the local maxima to reach the global maxima. For that, you need to randomize.
Yes.
So that you can give higher numbers. That's the better, right? But it will cause you to overshoot and affect your convergence, right? Am I right? Or I'm speaking something that you do not relate to.
Yeah, it's like that because when you do the hill climbing, like you say, you have the local maximum, and the algorithm will stop at the local maximum.
Mm.
But this one, the randomize is to make it to go back. If it reached the local maximum multiple times, it will go back and search if there is a higher value. Means
Okay, so it's
Yeah.
like, okay, fine. Then what about the lower tab, like simulated annealing?
sorry, which one?
The simulated annealing, what do you usually use it or you don't use
Oh,
it?
this one I don't touch it. This one I
You
think
don't
we'll
use it.
simply don't touch it.
Okay, now you give okay, right?
Yeah, we
Okay.
click okay. We only configure this two. This
So
one is
the usual number
this
is 10,000 and 25.
Yes.
What is NAHC, SAHC, any idea?
This one
HC is hill climbing, but what
Because
is
it's-
NAHC?
this one is you can see when you adjust this, the randomize is actually 100.
Okay, okay, no problem. You can carry on.
Okay, I cannot describe it clearly. Sorry.
Okay. So usual number is 10,025. So that's the takeaway from this portion, right?
Yeah, according to Bunch, the manual it recommends
yeah.
at the randomize as 25.
Okay. The recommended value for the population sizes.
That one it doesn't have a
Okay.
recognized value
Okay.
because for different program you might have different population size.
Okay. So this is okay. You okay.
Okay. And one more thing we need to configure is clustering options. This one we don't need to touch. The incremental MQ weighted.
Okay.
This is the bunch algorithm which I do not understand.
Okay.
I don't touch it. But this we only focus on this output level.
Okay.
Output level means the
Granularity of the clusters.
yes.
Granularity of the modules.
Yeah.
Okay.
Theoretically, when we have the detailed level output, there will be more clusters, but less packages.
Elements in every cluster.
Yes. And if we have higher level, we'll have less cluster and but much more packages in
Yeah.
each one.
So, what about median?
Hmm?
I mean, detailed is like that.
Yes.
What about median?
Uh,
Median.
you mean median?
Yeah. Okay, detailed will give you smaller clusters, large in number.
Yes.
But
Median.
high level will give you larger clusters, small in number,
Yes.
and median will give a balanced.
Yes.
output.
Yeah.
Okay.
The recommended output level is medium,
Medium.
by bunch manual.
Okay.
And we also can use this, but I tried it doesn't work. I don't know why.
What is the generated from?
Theoretically, this one, if you take this one, it will give all the output levels.
Oh, okay. But you go to the drop down,
Yes.
then it output all levels, right? What is the difference like if you don't put a tick and then you still give output all levels?
From the all levels.
You have not tried this.
Yeah, I tried this, but
Okay, then you can.
because the result is the same, I cannot figure out which one
Okay.
actually
Okay,
working.
it's now it's not very important. Like you already followed the guideline, which is the median. So that's what we are going to report, right?
Yes.
We don't need all levels. If they say median is better, if the paper suggests median, then we use median.
Yeah.
Okay.
Okay. So we just stay on the medium level.
Okay. And then when you whatever else.
And others we don't need to give. Actually, we need to give the orphans here.
Omnipresent. I think that is why you need to give orphans.
Yeah, the omnipresent.
Yeah.
This one is where we need to give the orphan.
Orphan. Yeah.
But
How do you do?
because I didn't recognize the problem, I fix it manually with the code, so we don't use the bunch.
This is very very sophisticated when you look at it. Like I think this is very very good.
Yes.
Okay. I did not know they have a provision to clearly specify what libraries are and what the actual portion of code is, user written code, and what is an omnipresent module. Okay. So you can also give your own clustering algorithm, which
Yeah.
means we can give the AP. If we write the code for AP in Java,
Mhm.
probably we can use the user-driven clustering and replace hill climbing with AP.
Yeah.
So
That's
bunch is a suite in
Mhm.
which you can integrate your code also, if I'm not wrong, right?
Yeah, that's true.
Okay.
Bunch allows that.
Oh, very good.
Okay, now we can run it and to have our dirty file.
Okay.
Because this is a very small very small application. So even we run it 10,000 times, it will take only
Few seconds to
seconds.
converge.
yeah.
Okay, let's view the graph.
No, we cannot build the graph.
Oh, is it?
There's a problem with bunch.
Okay.
Maybe not with bunch, but with the.
But you used to show me some PDF files and something like that. You're not going to show it.
Yeah, that one. That one is not here already.
Okay, fine.
So we can see the output here. This is the dirty file we have. Dirty file is actually it's designed for show the graph actually, but as long as we are dealing with the format conversion, we actually need the text version of this. So this is a dot file. It can be.
Do you guys use GraphVis? Have you heard of GraphVis?
You told me about that.
You may have used it. PyDot. Have you heard of PyDot? Python dot module. PyDot
Which
Py
one?
GraphVis.
Graph.
Python GraphVis. Py GraphVis. Have you heard of that? PyDot. PyDot also you have not heard. Okay, actually this one, yeah, this one from this place you can download this GraphVis. So this will take. This is a software to download. Sorry, to display the dot files. So directly you can use this and it will produce a colorful, better looking graph.
Yes.
The text that goes into the graph is what he showed in the Notepad++. Yeah. So it will say digraph G. The name of the graph is G. It's a directed graph, so that's why it says digraph. And its size is, it has 10 nodes. So the rotate and all is about the orientation. And then subgraph is something which comes under a particular box inside the graph. A graph is a big one with all the nodes, but a subgraph is a small portion of it. So it's like a semantics which will, like you can see in the 14th line there is a color of every node, the text color, the shape, and things like that. The nodes will be ellipses. So it's about visualizing the graph. So it's a text file which serves as the semantics for the visualization.
Yes.
Okay. So we can interpret it in the way that we want. Like if we want to build a matrix with this, we can ignore the color, the thing and all, but we can just take the name of the node and the value, the number, right?
Yes.
Okay, so
So this is the output of bunch, and we want to get the clustering information here,
okay.
and we can.
So what does it say now actually in cluster 0? How many nodes are there?
Here we have this cluster 0, and we have 1, 2, 3, 4, 5, 6, 7 packages.
Packages in one cluster.
Yes.
Okay. Now 22. Yeah.
Then we have the second cluster, which have
Two
one,
packages.
2 packages. These are all the dependencies, the lines. In the graph, you will say the lines.
But then 7 plus 2 is just 9, right? How about the 10th one?
Let me see. 1, 2, 3, 4, 5, 6, 7. 8, 9.
You had 12 and one was often.
Yes.
So it has to be 11 by 11.
Let me check this one. Sorry. Let me go to the result and check.
That's why I asked whether you can open it in a dot file. Can it be opened? Because it's producing only 2 clusters, right?
Yes.
And remaining things, does it ignore or does it consider a singleton cluster? Because I think that's why bunch results are maybe very poor. You see, it's not even agreeing with the input.
Yeah.
Because in the input you give 11 packages, and the output it only clusters around 9. So it's for a small application. And imagine what happens for a bigger application. Like it may even ignore more packages and maybe produce inconsistent clusters.
Okay, maybe I try to get this. I think it's because of the bunch only consider the dependencies. It does not consider the package itself. So, if anything.
Then I think you have to, okay, whatever bunch, okay, let us say this example contains
Yes.
12 labels, and out of them one is an orphan. So you input 11. So the graph is 11 by 11 matrix.
Yes.
But out comes only 9 by 9, right? Because it ignored 2. So what I would suggest is, can you consider those 2 like the way you consider the orphans, and also supplement the result given by the .e file?
You mean give the.
You consider them as individual clusters,
Okay.
as though bunch has given you them as an individual cluster,
Okay.
right? Can you do that and then check whether the bunch accuracy improves? Because I'm sure if that's the case, bunch accuracy will improve, because it's far below the
Yes.
acceptable level.
I think I can do that.
Can you, okay, before going to do that, can you find out what 2 packages that bunch left out in
Okay,
this
sure.
case.
Let me see.
Okay, how
I'll
many
just check
Android
from the
support
RSS.
users?
Should be okay. 1, 2, 3.
How
There's
many
one.
Android
There's
support
one Android support missing.
What
Android
is-
support has 6 labels, 6 packages, but there are only 5.
App content, OS,
Yeah.
utility.
Widget. Widget.
Okay, can you go to the matrix and find out what is widgets incoming and outgoing dependencies? It's in the Excel file, yeah. Widget, can you highlight 6? So, there is no incoming, there is no outgoing, there is
But-
only cohesion.
Yeah.
So that is already reduced to 0, right? So if you 6,
Ah, I see.
right?
Yes.
Okay, let's go to the other one. I think probably it will
The
be
writer, yeah, this one. Because
Yeah.
the bunch reduced the
reduces.
to 0.
So, bunch assumes them as singleton clusters. That's the reason why we see bunch perform so poorly and give us only 27% accuracy. It's a mistake that we committed and we blame bunch for that. Oh my god, we wrote it even in the paper and next week we had we made a fool of ourselves. But okay,
Okay.
I think this is very serious and we need to correct it.
Yes.
But I'm not sure.
The correction should be easy.
This is only for one application, but I'm sure when the application is larger,
Yeah.
this
there will-
scenario might happen many times.
Yes.
Even for the case of an application with 12 packages, we see one orphan package, 2 self-contained packages. So these self-contained in turn becomes as orphans, right? Because the self-dependency is always considered as 0 by bunch. So it's quite very poor, the bunch output. Normally, we have to supplement it.
Okay.
Okay, can you just make sure that the other package is reader, because we just guessed it right. Can we just go to the output?
The output of bunch.
Yeah, bunch. Can you search for reader? Not here.
Huh?
Not this format. The LL0, LL1, that format.
Right?
The other more. Yeah, this one.
You mean reader?
Yeah, reader is there.
Yeah,
Writer
writer.
is what one
Yeah.
which had.
Writer is not there.
Okay.
You can see from here.
Yeah, yeah.
Writer is
From
not there.
80 Tom cache, Tom hash, it's only reader.
Mm.
So there is no value for writer. Okay, can we try to fix it?
Sure, no problem. I can fix it here. Because
yeah,
of-
I mean, offline.
Ah, yeah.
Yeah, okay. So we have 10 minutes left, I think. So we will stop here. We will wrap up. I'm not sure whether there is a meeting in this room after we go. So I think probably we'll wrap up. We will continue it tomorrow. Since, today evening, if you're available, maybe we can go back to that.
Okay.
So it's your choice.
I think maybe we go to lab and finish.
And then we will finish up using the project.
Are you free?
No, I'm free, so
I'm free.
it depends. If you want to, you can join, or if you have some other commitment. Because we naturally expected this to go beyond 1.5 hours because it's around 1 year work, so it's natural. Maybe we can continue it later. If you're busy, you can leave. If you want to join, you can join us later. Okay, so we will wrap up.
Okay.